Welcome to another video. So in this tutorial, we are going to look at this MIT Integration B question of 2023 semi-final. So let's dive right into this integral. So this integral, I'm going to start off by letting our integrand here, y, to be equal to, that is x plus the square root of x squared minus 1 raised to the power 1 over 3 plus x minus the square root of x squared minus 1 raised to the power 1 over 3. The cube root can be expressed as to the power 1/3, right? And what I'm going to do here next is to take the cube on both sides. So taking the cube on both sides, before we proceed with the video, we have to know this. We have to know that a plus b all raised to the power 3 is the same as a cubed plus b cubed plus 3a squared b plus 3ab squared, right? This can be expressed as a cubed plus b cubed plus 3ab into a plus b, right? So knowing this, we can take the cube on both sides. I'm sorry about that. Taking the cube on both sides of this equation, the left-hand side is going to be y cubed and the right-hand side is going to be x plus the square root of x squared minus 1. This one raised to the power 1/3 plus x minus the square root of x squared minus 1. This one raised to the power 1/3, or this one raised to the power 3. That is cubing both sides. Now we are going to apply this one here. So this is like A and this is B, right? So we can just expand this one now. So that is going to be A cubed, which is this one cubed is going to be, the 3 is going to cancel the 3 on top, leaving to the power 1. That is just going to be x plus the square root of x squared minus 1. Plus this one cubed, that is the B, that is going to be x minus the square root of x squared minus 1. Like this. So this is a cubed plus b cubed plus 3 times ab. So what is a? This is a, which is x plus the square root of x squared minus 1 raised to the power 1/3 times b. And what is b? X minus the square root of x squared minus 1 raised to the power 1/3. That is this guy here, into a plus b. This is a and this is b. But the sum of a plus b is y. That is from here, our integrand. Our integrand is just the sum of a plus b. So instead of writing a plus b, which is this guy plus this guy, I'm just going to write y here, right? So y cubed is going to be this guy and this guy cancels. And we are left with 2x, that is x plus x, and then plus these guys, because they're all to the same power 1/3, I am going to multiply the terms in the cube root and a difference of 2 squares, right? So that is going to be x squared minus the square of this guy, and the square of that is going to be x squared minus 1. All this one raised to the power 1/3 times y. So we have y cubed is going to be 2x plus this one cancels, leaving 1 raised to the power 1/3 times y. So in the end, I'm forgetting something. There's 3 here that I'm forgetting. I'm sorry about that. So now you are getting 2x plus 3y, because 1 raised to the power 1/3 is 1. So y cubed is going to be equal to 2x plus 3y. So we can isolate x from here. X is going to be equal to y cubed minus 3y all over 2. So this is an expression for x in terms of y. Now let's find an expression for dx in terms of y. So that is going to be 3y squared minus 3 all over 2. So that implies that dx is going to be 3y squared minus 3 all over 2, all this one times dy. So we have found an expression for dx in terms of y that we can plug into our integral. Now this is y. We have an expression for this in terms of y. Now the next task is to find the limits for y. The lower limit for x is 1 and the upper limit is 9. So let's switch colors, why not? So when x is equals to 1, that is the lower limit. If you plug that here, 1 is going to be equal to y cubed minus 3y all over 2. So that implies that we have 2 to be equal to y cubed minus 3y. What will be the value of y here? That will be equal to 2 in the left hand side. Well, we can see that y here is going to be equal to 2, because 2 raised to the power 3 minus 3 times 2 is going to be 8 minus 6, and that is equal to 2. That will satisfy the value in the left hand side. So when x is equals to 1, y is going to be equal to 2. Okay, now the upper limit. When x is equals to 9, what will be the value of y? We can plug that in here. So when x is 9 is equals to y cubed minus 3y all over 2. So that implies that we have 18 to be equal to y cubed minus 3y. What will be the value of y here in the right hand side? And that will be equal to 18 in the left hand side. Well, when y is equal to 3, that is 3 raised to the power 3 minus 3 times 3. That is going to be 27 minus 9, and that is equal to 18. So that satisfies the value in the left hand side. So when x is equals to 9, y is going to be equal to 3 from this equation. So there we have our limits. Y will change from 2 to 3. Now we can take our integral now really from the x world into the y world. So our integral I is going to be the integral from 2 to 3 now of y times dx, right here. So this one is y, that is our integrand, times dx. Dx, an expression for dx in terms of y is here. So that is going to be y times 3y squared minus 3 all over 2 dy, like that. Okay, cool. I is going to be 1/2 is a constant. It goes in front. The integral from 2 to 3 of, we can multiply terms out. 3y to the power 3 minus 3y. All this one dy. This is now very easy to integrate. So integrating this one is going to be 3 over 4y raised to the power 4 minus 3 over 2 y squared. The limits of integration from 2 to 3. Now I is going to be 1/2. You can plug in your upper limit first. So 3 over 4, 3 raised to the power 4 minus 3 over 2. That is 3 squared. This is the upper limit. Minus plugging in the lower limit. That is 3 over 4 minus times 2 raised to the power 4 minus 3 over 2 times 2 raised to the power 2. Like this. Cool. So I is going to be 1/2 all the way in front. 3 raised to the power 4 is 81. 81 times 3 is 243 over 4. Minus 3 squared is 9 times 3, that is 27 over 2. Minus 2 to the power 4 is 16. 16 over 4 is 4, and then that's going to give you 12. And this one, 4 over 2 is 2 times 3, which is 6. So that is minus, that is going to be plus 6. Cool. So I is going to be 1/2. And then 243 over 8. So let's multiply in by the 1/2 now. I think everything you can multiply in by 1/2 is safe now. So that is going to be 243 over 8 minus 27 over 4. These ones will sum to -6, and taking half of that is going to give you -3. And simplifying this one is going to be 243 over 8. Multiply this one by 2 to the numerator and the denominator. That is going to give you 54 over 8 minus multiply 8. That is going to give you 24 over 8. And then you can now subtract. So that is 8. So that's going to give you 243 minus 54 minus 24. And that is going to give you 165 over 8 if you work that one out. So our integral I evaluates to 165 over 8. So if we integrate this one, that is going to simplify to 165 over 8. So remember, if you have this kind of integrals, which is very difficult, you just let y to be equal to this. You try to expand it and then find an expression for dx in terms of y. Try to change the limits of integration from x into y, and then the integral will become very trivial for you to integrate. And performing that leads to 165 over 8, which agrees with the answer that MIT gave. So if you really find this helpful, make sure to leave me a thumbs up, subscribe to my channel for more engaging content from Calculus Diaries. I thank you so much for watching this video, and I will catch you up in the next one. Bye bye.